Good evening, or at least it's good evening when I'm recording this. So I have some more code for you to present, in large part because my students in paleoecology are currently dealing with this for a lab, so I thought it would be useful to go about explaining how this works. So last time in my Data Science for Paleontology series, we talked about the R programming language and its basic workflow. Today, we're going to add a little bit to the basic workflow, some more sections in the order I like to put them. We're going to add some extra data processing, and we're going to talk about some base R stuff that can be very handy. So, if you're familiar with Python, and I started with Python, I was programming for years in Python before switching to R. Let's say you had two lists and you wanted to add the ith member of one list to the ith member of another and create a new list. If you wanted to do that in Python, in base Python rather, you'd have to use a loop. Something like start a new list, call it z for I in range length of x. Um, our sum is equal to the ith member of x plus the ith member of y, and then we're going to append that sum to our new list. So one of the advantages R definitely does have is that if you have vectorized data, you can just add the vectors. So let's say x and here y is equal to x squared. If I wanted to add these together, all I have to do is z equals x plus y. And if I run this, and including z, you can see that it creates a new vector, which is the sums of the previous ones. Now we can add some complexity by making these into a data frame. A data frame is technically distinct from a matrix, but for our purposes right now, it's basically a matrix. So we run this, and let's see what happens when we run W. You can see we'll get x, y, z, 1, 2, 3, 4, 5, and we'll get, so x squared plus x. So one of the advantages of R is we can directly vectorize our data frames. So we can vectorize um, the first column, for example, of W. You see, we'll get that. Or we can vectorize first row, second column. We can vectorize the second column, or really any row or column we can vectorize. And now, if we wanted to do something to multiple vectors, that's when we would start needing to bust out our loops. So, for example, we might say, well, I want to take every column and I want to double its value. We can use a for loop, and the syntax is a little bit more complicated here than it is in Python. We have these for as a function, and we have the curly brackets, which is similar to JavaScript, but very different from Python. So we can do that. We can do this for loop, going to take every column of W and double it. And if we do that and we run it, we can see that now we have 2x, 2x, 2 times quantity x squared, and then 2 times quantity x squared plus x. We have other kinds of loops. So we have if loops. We can have loops which are conditional. So if something holds true, then take an action. And then we have while loops. And while loops, though, are a little bit dangerous because typically you start with some parameter, let's call it b, and you say, well, why while b is less than some number, let's say it's a, right, rather than 0, that doesn't make sense. Um, you know, while this is going on, keep doing this thing. And then each time you do the thing, each time you cycle through it, you're going to add 1 to b. And then once b gets greater than a, you're going to stop. If you don't specify these parameters very precisely, you will generate an infinite loop. and you will be often forced to force the program to halt and restart it. So it's something you should try to avoid if possible. But I also want to talk a little bit about functions. So we can make functions ourselves in R that do specific things. And so in this data frame, I tend, in my workflow, so in this script and in my workflow, I tend to put functions defined after import data. Sometimes I'll put it before, but it should be around here, and it should be its own section just to keep them separate. So I want to talk briefly about this kind of problem. So in paleontology, paleoecology, we're often dealing with these data sets that we can look at this talk. That's a data set that's sort of in the raw. And I suspect next time we'll talk about how to do some pre-processing in Excel. But for right now, so we've got some metadata, in this case, the depth at which the fossil pollen was found and its calibrated years in carbon-14 years. And then you have taxes. These are all taxa, excuse me. These are all species of trees. And we might want to convert this from raw counts into relative abundance. That's a lot of times much more useful. And there are ways to do this in Excel, but a lot of times it's faster in R. So I thought we'd go about defining a function in R that can do this. And I certainly need this for my own research, so I've sort of decided to formally define a function with some flexibility, even though it's probably not entirely necessary to define it to this degree. So I've decided to define my function as count to perk. And this function is going to input a data frame, and it's going to input our first column with actual data. So if you look back here, so this is, remember that in R, unlike Python, we start our indexes at 1, whereas Python we started at 0. So this is 1, 2, 3. So column 3 is where our relevant data begins. Python starts at 0, so it'd be 0, 1, 2, and we'd put 2 there. So our data frame, the spot in the data frame where we want our real data to start, and then we're going to add a vector of names to name our new columns. And then this value is going to be, if you want it in percent, set this to 100. If you want it to remain as a decimal or a fraction, just set this to 1. Now I want to install some flexibility. I'm going to use this if missing statement, and that allows us to supply defaults. So I'm going to put in defaults for all 3 of these values. So in that case, all you have to do is put in count to perk of your desired data frame, and it will assume that it's the first column, and it will assume you want the column names, and it will assume you want percents, and it will do the rest. So you can use this if missing statement to fill in defaults. Here we're going to define some of our parameters. So the maximum number of columns, the maximum number of rows, n, which is our starting column, the number of metadata columns, which I've defined as p. Then we're going to want to open up a temporary data frame. I've got to find a better method for doing this because it inserts an extra column that really shouldn't be there, and then we'll have to fix it. But we can now go through and define other defaults. The only reason I defined n first was because it's needed in the p statement. So after we've done that, we're going to go through and we're going to use a loop. And this loop is going to build a vector called tot, which is the sum of all the row totals. So this is the total counts of all species. And once we have that, we're then going to go through an if loop for the simple case where n is 1, the default case, and the more complicated case where we have some metadata. For the simple case, we're just going to go through and divide each row by its row total, which we calculated in tote, times our, let's say, 100%. And we're going to bind these together, and we're going to add our names, and then we're going to write them out. The reason I use perk for both things here is that so that I can use one return statement, perk. Now for the complicated case where we do have metadata, we're going to use this if command to indicate that. We're going to pull the metadata separately and then recombine it at the end. And again, we have this interesting problem where it seems to be inserting an extra column. So I've had to add some extra code down here where I use it to fix that, and hopefully I will be able to rectify that soon. So before we do that, let's do some data post-processing though. I don't like that I have these NAs. That's going to play havoc with my calculation. So if I run this line of code, this will replace every NA with a 0 value. Then all we should have to do is run count to perk, and because it has metadata, it starts at the 3 column. It's going to take the name of the data frame, and it's going to take the first column of data. When I run it, no issues, good. Come over here, and you can see that the first species has had this insertion, and then if we go into the end, we have this NA, and really this should all be shifted over 1. So what I'm going to do is I am going to write this patch, and when I do that, now everything lines up correctly. And I'm going to figure out why that error is occurring and remove it. But for right now, I think it works as a good example. So I also want to just say, I think, especially when you're developing functions, it's useful to test, to take out pieces of the code and test it here. So like always appended to the end of my scripts are notes and test code patches and all that stuff. So I think that's going to just about wrap it up for this entry in R for Paleontologists. We'll see you next time. Bye-bye.